Gracias a todos por las...
Thank you very much for your outstanding presentation, Hans. I have one question for you. Taking into account that we're talking about a product, a bacteria in its origin, should we expect to find adverse reactions or any reactions to that bacteria, maybe an immunological response?
I answer in English, okay. I will answer in English, but I understood your question. So actually, in the beginning, that was my major worry, okay? But it turned out that first of all, these molecules are very small, okay? They are below 1,000 Dalton, which is something like a limit below substances are not immunological. And this is exactly what we see. We tried over years to develop antibodies against these compounds, and we constantly failed. It's a nightmare because they are not immunological, okay? And maybe one thing that convinces you even more, when you look at the experiments that we did, where we treat, then we don't treat for 2 months, we treat again. This is actually a perfect immunization experiment, right? Where you immunize and then you wait and then you boost, and nothing happened. So that's good news.
Quería hacer también una pregunta.
I have a question. Thank you again for these presentations. And this is a question for Dr. Zischka. What do you think, or have you used detox systems for the mitochondria? Have you tried to detox, for example, citrate or Q10 coenzyme or carnitine? Could they improve the functioning of that mitochondria?
As I said, we are with the mitochondria at an essential function for the cell. And these organelles are constantly degraded and renewed in order to keep the cells alive. And thus, you can easily imagine that understanding this process, what are the signals from a mitochondria that is not working great again to be degraded, and what are the signals the cell needs to make new ones. These are currently under heavy investigation because the hope is to develop something like drugs where we all would stay young. And indeed, one thing is actually interesting. Currently, the only really proven method to use this degradation process is starvation, where you reuse compounds. And I know several compounds that are currently being tested to push this process. Also the group from Gloria, they also try to especially develop such drugs to initiate this process. So that's dealing with this to renew mitochondria. Okay. The other part of your question is how can we keep them alive and powerful? And there have been many trials, especially with this idea against oxidative stress. Yeah? For example, Linus Pauling, who won 2 Nobel Prizes, he thought vitamin C is the ultimate drug, which failed. It is not. So in my opinion, healthy lifestyle together with physical activity is the best to keep your mitochondria fit.
Thank you for all the presentation. I have a question for Gloria. You said that the genetic modified invading the liver. You push a little quantity in the liver of recombinant gene, and then it's spread in the liver, right? Okay, I didn't say my question. I'm just asking. My question is that how do you explain that the gene therapy that you inject in the mouse provide in the liver? How did it spread? What's the mechanism underlying? Is it specific to the liver because of the property of regeneration, or it can be in other organs?
Yeah. First, we are using a vector which is hepatotropic. I mean, it has a preference to go to the liver and to the hepatocytes, but the main thing is that we restricted the expression of the protein using a hepatocyte-specific promoter. So the vector maybe is in other, maybe no, it is in other organs, but there is no expression at all.
Gloria, una pregunta.
Gloria, I have a question for you. The idea is when you do genetic therapy, when you do GT, so you're actually placing there, could you have an effect for life because they're going to be replicated in other hepatocytes, or because you're talking about an adult liver, that will not work? But if in an adult that is not presented with any injury where the hepatocytes will divide themselves, the duration of the vector after an injection should last for several years. We don't know yet how many years the expression is going to last, but based on studies that we have done with hemophilia B, so that is based in AAVs, and what they do is they express coagulation factor 9, FAC9. They estimate over 10 years or more. But we don't know if it's going to be the same for us. But if we are talking about a normal liver and a structural liver, we believe we're talking about 10 years. And in hemophilia, do you know if you have a lot of fatty acid, fatty liver now? Do you know if that's going to have, or have you studied? Have you done a parallel study regarding fatty liver and hemophilic patients? Will that have an effect on the duration? Well, what we have seen in the hemophilia clinical trial is that it's going to vary from patient to patient. Not all patients that are treated with the same dosage, the coagulation factors are going to be the same. So that's going probably to be related to the status of the liver, whether there's more or less inflammation, whether it's more or less fat, but we still have no results. But what we do know based on animal models is that fibrosis that could affect that transduction of the liver, but fatty liver or not, we don't know. I wanted to ask you, Carmen, regarding the microRNAs, which is very interesting to see the differentiation between Wilson and control patients. This increase of the MIR122, which is unspecified. Have you seen this, or have you adjusted this based on whether Wilson patients that you include have had a given treatment or not, or if they are presented with other hepatic concomitant diseases? No, no. No, what we have done just had the biochem battery of tests. But yeah, I understand where you're coming from. Actually, I forgot to let you know, because this was a study. This was pretty much the classic study comparing a control healthy versus those with the disease. Now, thanks to the collaboration coming from Marina, every time the patient goes to the clinic, just like you do on all values, and we do extraction of plasma to see to what extent it would be interesting to incorporate this so we can follow up the patient. And to that extent, we will take into account and we will have a clearer idea about progression of the disease, also treatment.
Well, they are actually two questions, but I think they are quite correlated, so if you could answer both. So firstly, how is the microorganism introduced in the body? And then how does the introduction of this microorganism affect the natural gut microbiota?
Thank you for this question, because there is a misunderstanding. We don't introduce the microorganism. We just incubate it with this little compound, the methanobactin, okay? And the cool thing is, we grow these bacteria, we, colleagues in the US, and because the bacteria throw this compound out, we just fish it from the supernatant and we clean it a little bit, and then we go in the animals with it. But we don't inject the bacteria, okay?
Okay, thank you.
For
Yeah, thanks for the declaration. Yeah.
Well, I have a question to the two presenters from the Canary Island. If we start genetic screening on newborns, we will find in Spain, for example, we will find a number of newborns who are homozygous for the Spanish mutation. And you also show that even that most likely it's only a fraction of those that will develop Wilson's disease in the end, or will be diagnosed with Wilson's disease. So how do we deal with that situation? We have a patient, we have a newborn with 2 mutations that theoretically can produce Wilson's disease, but may not always do it. So what to do in that situation?
That's a situation that was up at the newborn genomes.
Yeah.
What do you do with people that have mutations? That's why you need to know exactly what's the evolution of the disease to make some statements. So if you find people have 2 strong mutations, you may think that for sure they're going to develop the disease. But we don't know what's all those are homozygous that we are missing. We don't even know what's the disease like in these people. It's a challenge. Also, we have never, all treatments for Wilson's disease have been developed in symptomatic individuals. What are we going to do with the asymptomatic? It's things that we ought to think about. So we, rather than bringing solutions, we brought problems to it. Sorry.
Thank you. Nice answer.
Well, from my point of view, quite close to Antonio. That's the reason we are so interested on genetic studies. It's not a problem of diagnosis. You can diagnose properly a patient without genetic studies. But the genetic studies will give us some explanations about the disease, about the significance, the meaning of the mutation. Really, we don't know. If my hypothesis is that there is a lot of Spanish people walking around the country with two mutations, with mutations in both genes. But as far as we cannot get them, we cannot say you are ill, you are not ill, you are barely ill. Perhaps there are, well, everybody says that there may be another factors. Diet, exercise, I don't know if exercise is so good. Perhaps if you are a good sportman or sportwoman and you have both genes with methionine, 645, arginine, perhaps you don't develop the disease, or a very severe disease. You have some kind of steatosis. Well, okay. So that's the reason we are so interested on genetics, and we are so interested to convince our government to help us to screen some kind of knowledge of what's happening with the genes in our patients, in our country. In Europe, the mutation 1069 is quite different. Perhaps it is not a good place in Austria or in Poland to study that, because they have a high proportion of a quite a strong mutation. But in Spain, we are lucky or not, it depends how do you consider. We have both. We have 1069, we have the Canarian mutation, and also the Spanish or Jewish mutation, because it's quite frequent in Ashkenazi population. So it's quite interesting to increase the knowledge about the disease or the mutation.
Hello, I have actually no questions, so I will try to do this as short as possible. I only wanted to say to Dr. Hans a special thank you, because you added that humoristical tone in your slides. And I would really like, well, I appreciate it as a teacher and also as a university student. And I would really like to encourage you to finish the slides next year.